We use the multiplication formula when we have two or more groups from which we can make selections and we want to determine how many different arrangements we could have with those two or more different groups. And remember, this is the multiplication formula, not to be confused with the multiplication rule from an earlier session. So in this example here, we have Dr. DeLong has 10 shirts and 8 ties. How many shirt and tie outfits does he have? Using the formula of M times N equals the total number of arrangements, we see that Dr. DeLong has 10 shirts and, and 8 ties, equaling 80 different possible arrangements. Let's look at a different example. This example, we're talking about a car dealer selling a $29,999 car, and that car can either be a convertible, a two-door sedan, or a four-door model. And each of those choices can have either wire wheel covers, or solid wheel covers. How many different arrangements of models and wheel covers can the dealer offer for that $29,999 price? So if we use the multiplication formula, the total number of arrangements equals M times N. We'll see that the formula equates to 3 different car options, convertible, two-door, or four-door, and 2 different wheel options, either wire wheel cover or a solid wheel cover. It gives us 6 total options. Now, what you can see is that we can easily count and display all of the different options right here, even with the fancy car depiction themselves rather than just a little boxy car. What would happen, though, if our numbers got bigger? What happened if we were to add a 4th car choice, say a hybrid two-door, and we added the option of either a CD player or an MP3 player? Well, the 4th car choice would just change our M to a 4. Our wheel covers would stay the same because we would make that available on any of the 4 options for the car type, body type, but yet we would have a 3rd now option for our media. So the total number of arrangements in the multiplication formula can equal more than just 2 options. We just extend out the formula to be M times N times O. So in our example, we would have the total number of arrangements is equal to 4 different car types, the 3 that are listed here plus the hybrid, 2 different wheel cover types because I didn't add anything there, and then 2 different music options or media options, which equates to 4 times 2 times 2, which equals 16. Now, in each of these multiplication examples, we've had 2 or more groupings from which we made choices. What would happen if we have only 1 group of objects? And that's where permutations come into play. But before we discuss the permutations, we'll take a brief stop at factorials. You probably have seen this before. Factorial before. Its notation is the number followed by the exclamation point, just as you see here, 0 factorial or n factorial. Like most statistics, this is very exciting stuff, hence the exclamation point. The factorial notation, it's just a simplified way of writing the product of the number times the next lower number times the next lower number until you reach the number 1. Note, 0 factorial is defined as 1. So once we have that, 5 factorial would just be 5 times 4 times 3 times 2 times 1, which equals 120. And we'll use these when we get on to permutations.